symmetry. If you know symmetry of a curve, then it can help sketching because you only have to sketch half of it and then you can reflect or rotate or whatever type of symmetry it happens to have. We have two special types of functions, odd functions and even functions. Now an odd function, the formal definition is function negative x is equal to the negative of function x. Visually, if you were to look at it, it has point symmetry, or sometimes called rotational symmetry, about the origin. So over there on the wall, I can see some odd functions. Which ones would be odd? The cubic would. If you rotate the cubic 180 degrees, you would get the same picture. So it has rotational symmetry. There's another one there that does that. Ah, I knew someone was going to fall for it. No, not the circle. Because the circle, remember, is not a function. So if it's not a function, it can't be an odd function. No, the other one's the hyperbola. Imagine rotating that 180 degrees, and yes, you would get the same picture. So once again, another example of, if you can see the picture, very easy to work out. Otherwise, if you have to prove it, function negative x is equal to negative function x. Spin it 180 degrees, it's going to look the same. So y equals x cubed would be 1. Y equals 1 on x would be 1. Y equals x to the power of 7 minus x to the 5th. Well, I actually don't know what that looks like, but it would be 1. Minus 3x to the 9 plus 2x to the 7. What do you notice about these polynomials and the powers? Odd. So when you're looking at a polynomial, if all the powers are odd, it's an odd function. All right, let's prove it. Let's prove x cubed plus x to the 7 is an odd function. To prove it, we have to use the definition. So function x is x cubed plus x to the 7. Function negative x, everywhere I see an x, replace it with negative x. I get negative x cubed plus negative x to the power of 7. Well, negative x cubed would be negative x cubed, and negative x to the power of 7 would be negative x to the power of 7. Because you'd be going negative times negative times negative times negative. 7 times, you'd end up with negative. Well, that, I can factorise negative out, and I in fact get the negative of function x. And so yes, it is equal to the negative of function x. So that's how you actually prove something is an odd function. Okay. Let's have a look at even then. Even functions, function negative x is equal to function x. This one has line symmetry. Which one there has line symmetry? It has an axis of symmetry. Parabola. Parabola has the axis of symmetry, so it is an even function. Any others up there? I was just wondering whether someone would fall for the circle again. No, okay. The y-axis is an axis of symmetry. So x squared, yes. X squared plus 4, yes. Minus 3x to the 6 plus 2x to the 4 minus 27x squared, yes. Notice all the powers are even. You might be looking at 4 and going, well, hang on, that power's not even because that's 4 to the power of 1. No, it's not. It's 4x to the power of 0. Is 0 an even number? Well, that's debatable. But it's in that pattern of every 2. So. And if you think about what that actually is, it's the parabola shifted up 4 units. So you haven't moved the axis of symmetry. So it's still an even function. Okay, let's prove it then, just in case you don't believe me, that x squared plus 4 is an even function. So again, function x. We test function negative x and see what happens. Minus x all squared would be x squared. So we get x squared plus 4. Oh, that's the same as function x. So yes, that is an even function. Not all functions are odd or even. If there's no symmetry, it's just a function. Just like all numbers aren't odd or even. You could have fractions, you could have decimals and things like that. Okay. 3C.